Ever since humanity first gazed at the night sky, the moon has captivated our imagination, a silent sentinel cloaked in mystery. Its scarred surface, visible even to the naked eye, whispers tales of cosmic collisions and ancient secrets. While the Apollo missions gave us our first close-up look, they only scratched the surface of the moon's enigma. Now, a new era of exploration is unfolding, driven by China's cutting-edge robotic missions. These tireless machines are rewriting what we thought we knew about our closest celestial neighbor, uncovering clues that could shape the future of human exploration beyond Earth. The Earth-Moon connection is unlike anything else in our solar system. Picture this. Among the rocky planets, Earth is the odd one out, paired with a moon so large it rivals the satellites of gas giants. Venus, Earth's near twin in size, drifts alone without a moon. Mars has two, but they're mere pebbles compared to our lunar companion, small enough to fit inside a mid-sized city. The gas giants boast massive moons, but their planets dwarf Earth in scale. What sets our moon apart isn't just its size, it's the uncanny similarity between its rocks and Earth's. When Apollo astronauts brought back lunar samples, scientists were stunned to find they mirrored Earth's geology, hinting at a shared origin story that defies the idea of separate formation. This brings us to the Great Impact hypothesis, a dramatic explanation for the moon's birth. Imagine a rogue planet roughly the size of Mars, slamming into a young molten Earth. The collision was cataclysmic, melting both bodies and flinging a torrent of debris into orbit. From this chaos, the moon coalesced, forged from the same material as Earth's core and crust. This theory accounts for their striking similarities, but it's not without gaps. Each new discovery on the moon raises fresh questions, reminding us that our understanding is still a work in progress. China's lunar ambitions have taken center stage in this quest for answers. Over the past few years, their space program has unleashed a fleet of robotic explorers, probing uncharted lunar terrain with precision. These missions are doing more than collecting data. They're challenging old assumptions and reshaping our view of the moon's past. One of China's boldest feats came in 2019 with the Chang'e 4 mission, the first to land on the moon's elusive far side, a region forever hidden from Earth's gaze. Nestled in the sprawling von Karman crater, roughly the size of a small country, the Yutu-2 rover set out to explore this alien landscape. Unlike the near side's dark lava-scarred plains, the far side is a rugged, crater-pocked expanse, pale and mysterious. Scientists have long puzzled over this stark contrast, and Chang'e 4 offered a front-row seat to unraveling the mystery. Yutu-2's most groundbreaking find was evidence of rocks from the moon's mantle, a layer buried deep beneath its crust. Until this mission, every lunar sample, from Apollo to Soviet probes, came from the surface crust. Discovering mantle material was like finding a hidden chapter in the moon's history, offering clues to its formation and evolution. These rocks, exposed by ancient impacts, provide a rare window into the moon's inner workings, transforming our understanding of its geological past. The Yutu-2 rover sparked a global frenzy when it beamed back images of a peculiar cube-like shape looming on the lunar horizon. For a fleeting moment, the internet buzzed with theories. Was this a cosmic relic? A nod to sci-fi classics like 2001: A Space Odyssey? The truth, revealed after closer inspection, was more grounded. Just a rock, its odd shape a trick of light and low-res imaging. Yet this moment captured the raw excitement of lunar exploration, where every shadow holds the promise of something extraordinary. China's lunar saga continued with the ambitious Chang'e 6 mission in 2024, zeroing in on the moon's South Pole basin. This wasn't just another landing. It was the first mission to scoop up samples from the far side and bring them back to Earth. These samples unveiled a startling contrast to the near side's geology. The far side material was lighter, clumpier, and stickier, with a texture unlike anything seen before. Even more surprising were the volcanic rocks. Some dated back a staggering 4.2 billion years, the oldest ever found, while others were as recent as 2.8 billion years, far younger than many Apollo samples. This suggests the Moon was a hotbed of geological activity for much longer than we ever imagined, forcing us to rethink its ancient timeline. These discoveries are flipping the script on what we thought we knew about the Moon. The Big Splash theory painted it as a small, quickly cooled body, with the far side holding the oldest volcanic remnants. But the mix of young and old volcanic rocks on both sides tells a different story, one of a moon that stayed molten and active for eons, defying earlier models of a dormant, frozen world. The Apollo missions, for all their glory, had limits. They touched down in flat, equatorial zones, safe but geologically tame, covering a mere 25 square kilometers, smaller than a theme park. China's robotic explorers, however, are free to roam rugged, uncharted terrain, unlocking secrets from regions Apollo couldn't reach. This broader scope is redefining our grasp of the Moon's complex history. China's missions are also uncovering treasures with implications far beyond science. The Chang'e 5 mission, a landmark sample return in 2020, targeted the Rumker Dome, a youthful volcanic feature in the Moon's northwest. The rocks it brought back were a revelation, dating to just 2 billion years ago, the youngest lunar samples ever studied. Among them was a game-changer, a transparent, crystal-like mineral dubbed, barely the size of a hair. This find held a bombshell, Helium-3, a scarce isotope with the potential to transform energy production on Earth. Helium-3, carried to the Moon's surface by the relentless solar wind, is a rarity on Earth, where our magnetic field blocks such cosmic gifts. This isotope holds immense promise as a fuel for nuclear fusion, a dream technology that could deliver boundless clean energy without the toxic legacy of traditional nuclear reactors. While fusion power remains on the horizon, the Moon's Helium-3 deposits position it as a potential energy goldmine, one that could someday light up our world. Equally transformative is the discovery of water in the lunar soil. The Chang'e 5 mission stunned scientists by finding water molecules not in shadowy craters, but on a volcanic slope, a hint that water might be far more common across the Moon than we ever thought. Locked within a newly identified mineral called ULM1, a hydrated salt, this H2O discovery rewrites the rules for lunar exploration. If water is widespread, future lunar outposts could thrive almost anywhere, not just in the rare polar regions once considered the only viable spots. China's lunar missions aren't just about decoding the past, they're paving the way for humanity's next giant leap. Unlike the Apollo mission's brief visits, a permanent lunar presence demands a deep understanding of the Moon's terrain, resources, and challenges. These robotic explorers are mapping water reserves, analyzing soil composition, and pinpointing Helium-3 deposits, building the blueprint for sustainable lunar bases. The global stage is watching. China's bold strides have reignited a lunar race, with nations like the United States accelerating their own missions, from crewed landings to robotic scouts. This isn't just competition, it's a chance for collaboration, as the Moon becomes a shared frontier for innovation and discovery. What was once a distant beacon in the night sky is now a vibrant hub of exploration. China's robots have revealed a Moon far more complex than we imagined, with diverse geology, untapped resources, and clues to our planet's origins. From Helium-3's energy potential to water's promise for sustaining life, the Moon is no longer just a destination. It's a cornerstone for humanity's future in the cosmos. Each mission brings us closer to unraveling its mysteries and harnessing its riches, not just for science, but for the dreams of a species reaching for the stars. If you could pick one lunar discovery, Helium-3 for clean energy, water for lunar bases, or mantle rocks revealing the moon's history. Which would you say is the most exciting for humanity's future in space, and why? Drop your thoughts below. Ever wondered what lies at the edge of the observable universe, where light fades and the cosmos stretches into the unknown? Our previous video, Beyond Horizons, takes you on a thrilling journey to explore the boundaries of what we can see, unraveling the mysteries of the universe's vast expanse. If you want to learn more, click on the recommended video above. If you enjoyed this video, I'd greatly appreciate it if you'd give it a like and share it with your friends. Thanks for watching.